Welcome back. I'm Tony Dubio, Cloud Architect working for Cisco. This is part two of a two-part demo series. Focus on using Ansible to configure OpenStack, as well as guest operating systems, and ultimately the application stack. If you recall from part one, we focus on the cloud admin and network admin and using Ansible as a configuration management and deployment tool set to configure resources and make them available on OpenStack for a later handoff, which we will focus on today, the handoff to the DevOps team. We also took a look at OpenStack, specifically Cisco Metacloud, where OpenStack is remotely built and deployed and day two managed from Cisco, meaning that Cisco is responsible for the updates and upgrades and the availability of OpenStack, and really manages the lifecycle management of the OpenStack and those services so that the customer doesn't have to. Really, the customer's responsibility is the admin function. So there's a handoff to the customer after we build these clouds. The customer takes the reins of admin. Now, we do provide an enhanced dashboard. We also provide orchestration through heat templates. But we're finding that a lot of our customers are really wanting a more holistic tool set. So in the specific example of this demonstration, we're using Ansible. And Ansible is very portable, and it would be considered an end-to-end configuration management and deployment toolset because it focuses on the infrastructure as a service, in this case the OpenStack APIs, which are key to allowing Ansible to provide modules that take advantage of those APIs to really simplify what's needed to configure and to consume the OpenStack resources. We're also able to take Ansible and focus into other layers as well. So today, we will also take a look at the guest operating systems and applications that we want to install, and we want to provide lifecycle management at that layer, where that would be a responsibility of a customer. So from feedback, anecdotal information from customers, they really don't want to use tools that are difficult and time consuming. So really, it's all about making these environments quickly available, rapidly delivered, as well as very portable in that they can become temporary environments that can be built and torn down and easily managed from the customer side of things. Today we're focusing on that handoff. Again, in the prior demo we focused on the cloud admin and network admin and their ability to build a project and make that project available for a tenant. Whether it's an internal or external user, somebody has to, create that project and make resources available. In our demonstration, we took a look at, adding a user, but then setting a quota. Specifically, we increased the quota to make more resources available for that specific project than the default amount. We also uploaded some images, some cloud-ready images, and we built a host aggregate which allowed us to take a specific workload and force it to land on specific hardware from a compute platform perspective. In effect, we can control where virtual machines land, and we can override the default nature of OpenStack. We also, secondly, here in the middle, transitioning to the network piece, we certainly were able to take advantage of the programmability of OpenStack and the Neutron service by using Ansible to create a private network, to build a virtual router that connected that specific project to the external network, and to build a security group that we can use to protect that project and the virtual machines that ultimately will be built in that handoff to the end user. Hence, the DevOps team. And this is the focus of today's demonstration, where we will again use Ansible, but from this perspective, we will focus some on the OpenStack APIs because we can take advantage of modules to build the virtual machine and to leverage specific images and to consume resources such as floating IPs to make the virtual machines accessible from the external network and internet, as well as mapping these virtual machines to the security groups that we previously built for the project. And then ultimately, taking Ansible and pointing it remotely to those virtual machines so that we can lifecycle manage the guest operating system by being able to update that component as part of the responsibility of DevOps, as well as installing software as part of our application stack. In this particular demo, we will install a web server and an HAproxy load balancer, and we will also update the configurations and make those resources available from the internet so that we can test a functioning load balancer, HAproxy load balancer with web services behind the load balancer. And all of this will be managed with Ansible, and much like we did in demo 1, we're able to build it and also tear it down using Ansible playbooks. So from this point, we're going to transition into the demo, and I hope you enjoy our focus on DevOps. In terms of background and to set the stage for the demo, we are using a Metapod project that was previously built in a trial environment. This particular view is the network topology, and we can see that we have a public network that is internet accessible. We've already built a router, and this router has a connection to that public network, as well as a connection to this priv1, this private network. As you can see, there's also a virtual machine built that is functioning as a jump box. This is the jump box that we will remotely access that has Ansible configured, as well as connectivity to this private network so that as we bring up other virtual machines, we will have local connectivity to lifecycle manage the guest operating systems and to build into lifecycle manage the application stack as well. We could do this remotely through floating IPs through the internet from your laptop as an example, but then we have to build more security groups and consume more floating IPs. So for the purpose of this demonstration, we're going to just leverage a jump box that we can remotely access and then have easy access through local connectivity in the network within this project. Having said that, let's go ahead and take a look at the command line, and we'll do a Nova list. Then we can also see the jump box that we're looking at, and this is the IP address that I've accessed, and this happens to be the jump box that we're on. This Ansible lab folder contains all of the YAML files that we will use for playbooks. If you recall from demo 1, we took a look at the construct of Ansible and the mechanics of using the Ansible config file to override any defaults. In our case, we use that to point to our host file. The host file is the inventory of hosts that we will connect to. And we took a look at the main YAML file where we would aggregate a list of playbooks that we want to launch as a group, and we drilled down into the syntax, the YAML syntax of a playbook, and we took a look at the variables file, which is very key to identifying the variables that we want to use within the playbooks and to set those parameters in our variables file so that we can repurpose these modules, and really all we need to change in effect is the variables themselves to make sense for the particular use case. So we'll go ahead and walk through some of these files first and set the stage and a level set of what we're building here in terms of building web servers in HAproxy and assigning a floating IP address so that we can ultimately connect to these devices. And then we'll execute the playbook itself and see it in action and validate that the environment is working, and then ultimately we'll tear everything down and clean up the project and remove the virtual machines that we have provisioned during this demonstration. So we'll go ahead and take a look at the Ansible config file. Start there. And much like demo 1, we're just overriding defaults, and we're pointing to a host file that's in this directory. So that's the main host file that we will point to. You'll also see a second host file that I've created for web servers that we'll point out in more detail in a few moments. Okay, we'll go ahead and take a look at the host file. And you can see that we have the local host. Again, we use that when we will launch a playbook that's leveraging OpenStack modules that would point remotely to the API of OpenStack. HAproxy is a group that we will use during this demonstration, and we will actually leverage Ansible's ability to update files to actually add the IP address of the HAproxy server that we will point to later in the demonstration. So you'll see this file populated as we move further into the demonstration. Okay, so let's go ahead and look at the Ansible playbooks that we will launch um, ultimately to build the virtual machines and to configure the guest operating systems and to update the application stack. What I've done is created a script, a batch script, so that we don't have to actually type out the configurations. So we'll use that to kind of set the stage and give us a framework from which we can understand how, in what order, we will chronologically launch these playbooks and stitch them together. We'll play. So in effect, this batch script that we've saved allows us to take the Ansible playbook commands and stitch them together so that we don't have to type all this stuff out. So let me walk you through what we're building here. So ultimately, there's an Ansible playbook to launch the main YAML, which happens to be an aggregation of multiple YAML files that we will launch within that single file. And then using the ampersands, we can launch an Ansible playbook, but this time we're using sudo so that we become root, and we can leverage the key that we need for SSH, because after we build the virtual machines in the main YAML, we're going to access them remotely and launch the subsequent YAML file here, apache.yaml, that installs Apache on two particular web servers, and then ampersands again to launch a subsequent playbook that would configure the HAproxy server and update the configuration file, and then ampersands again to launch playbooks for neutron port, which actually allows us to assign a port to the virtual machine to connect to the network, and then ultimately we would assign a floating IP, and that's what we're accomplishing in floatingip.yaml. So again, this is just to make it easier so I don't have to type all that stuff. I will either type source or dot, and then that batch script, and it's going to run that Ansible playbook, and then we would see it executed on the screen. Again, we would see the plays and the task, and we can watch them unfold as it is launched from the command line. But before we do that, let's go ahead and take a look at some of the other files that are necessary to perform this demonstration. We'll go ahead and take a look at the variables. Very important file. Key pair, security groups that we're going to use. The tenant is Metapod that we looked at over here. The user, and these IDs are specific IDs for the images. So we have an HAproxy image where HAproxy is already installed, but we need to update it and configure it. We have a image for a web server, which is actually just a cloud image for Ubuntu 14.4, and then we're going to install Apache and update Apache, and also copy some HTML files over to the web server so that we can see a web page that is not the default web page. We will configure the web servers, so we're giving them a name, as well as HAproxy virtual machine, and leveraging flavors so that we have a specific size of virtual machine that has the appropriate amount of CPU, memory, and storage for those workloads. As we move down, we have a private network that is already configured. It's the Priv1 network that we saw on the screen. And then floating ID is the that network, that's the public network, so that we can allocate a public IP address from that pool of floating IPs and assign it to our load balancer. So that way we hit our load balancer, and then from our load balancer, we hit the web servers that are load balanced in a round robin fashion behind the load balancer. Okay, so we'll go ahead and take a look at what we're doing in the main YAML. And that includes web server 1, 2, and the HAproxy server. Again, these are individual YAMLs, so we'll take a look at web server 1 and HAproxy to give you an idea of what we're doing there. Okay, this here is the web server 1.yaml file, so we'll go ahead and take a look at this as a sampling for both of the web servers. It's actually duplicated. So again, just like the YAML files that we remember from demo 1, we have to name the host file, which is local because, again, when we launch a web server, we're leveraging the APIs of OpenStack, and specifically this OS server is a module that's built for Ansible to point to those APIs to make it easier and simplify the configuration. Much like we did in the previous demo, present, we'll either build it if it's not already there. If we change this to absent, it will delete that resource that we built. We're using the variables. The name of web server 1 variable is actually web server 1 team 1. That was that was identified in the variable file that we looked at previously, as well as the image for a web server, a key pair, a flavor to allocate the right size of the virtual machine for this web server. Security group is default. I've opened port 80 so that we can access it from the internet. And then the net ID is the private network, which was priv1 was the name allocated to that private network that we see right here. Once we build the virtual machine, there's a couple other things that we're doing. Is we want to update the IP address to a couple of files. One file being the HAproxy.config file that's used to configure the HAproxy. We need to tell the HAproxy load balancer what the IP address is of web server 1 and web server 2. And we can validate that after we run the playbooks. We'll go back to this file and take a look at it. The second file is web host. If you recall, when we looked at the main host file, we had local hosts, but we also had a group called HAproxy. And at some point, we will update the IP address from a playbook of the HAproxy YAML that we'll take a look, server proxy, HAproxy server YAML that we'll take a look at next. We'll see that we're updating the host file. This web host is a second host file that we'll point to that has a group for the web servers that includes the IP addresses of those web servers, because we need to remotely access them using SSH. From this jump box that we have Ansible installed, we will remotely connect to the web server after it is built, and that's where we're going to ultimately move on to an apache.yaml file to install, well, first to update the Ubuntu operating system, guest operating system, but then secondly, we will install and update the Apache web server and copy some files, some web page files into the web servers. And then along those same lines, we're going to take HAproxy.yaml and update the HAproxy configuration as well. So we'll see all that in action, and it'll make more sense as we unpack the subsequent YAML files. Next one being HAproxy. Oops. HAproxy. Good grief. There we go. So same thing here, pointing to variable files. The HAproxy name is HAproxy team 1. We also have the image and the flavor. This is actually a mistake, so let's go ahead and fix this. So insert. before we do, well, actually, we'll go ahead and do that and go back into it. Here's the files that we're going to update. We're going to update the host file with the IP address of the HAproxy, as well as this here, which is the variables. We're going to add a variable called HAproxy IP into our var file. And again, we can validate this after we run the playbooks. But first, let's make sure that I called that the proper thing. Yeah, flavor underscore HA. All right, so let's take a look at the Apache. So in the Apache YAML, what we're doing is we're updating the Ubuntu image that we launched as a virtual machine, and we're using the user cloud with a key that allows us to access that virtual machine remotely. So SSH is being used from our jump box remotely to this virtual machine. We're pointing to the variable file for any variables that we need for this particular playbook. And here's what we're executing as shell commands. So these are Linux shell commands. So I'm using sudo because I'm accessing this as the cloud user. I need to sudo and have the appropriate privileges that allows me to update, root privileges that allow me to update the actual Ubuntu operating system. So we update it. Next, after we update it, we're going to install, in this shell script, Apache 2 web server. And then after we have a web server, we want to copy some files. So this copy command allows me to copy this image to the directory where the default directory where the HTML and images are kept. And then we also have the actual HTML itself, this index.html that we're going to copy to the web servers. So that's the Apache playbook. And then we also have the HAproxy playbook. So a lot's going on here as well. Again, these are all, configurations to the specific application. So Ubuntu was the guest operating system. We updated that. Then we installed Apache and updated some configuration files. And now we're going to update the HAproxy. So the image had HAproxy pre-installed, but we want to copy over our config file because our config file includes the IP addresses of the web servers. So we need to update that configuration. And as part of updating configuration in HAproxy, you need to restart the service. So that's what we're doing here is we're restarting the HAproxy service so that way it points to our web servers, and then we can leverage the load balancer to round robin load balance between the two web servers that we've deployed. Okay, so what's next? The floating IP address. So we have the Neutron port. In the Neutron port, we are, in this case, taking the HAproxy IP address, and we're listing that out to find its specific port. And then what we want to do is we want to make that available, that port ID, in our variables file. So we will see this updated into our variables file. And then I added another pause to give time to connect the port because we want to pause, and then we want to actually assign a floating IP. Okay, so let's go ahead and take a look at the pause here so you can see that. Again, it's only a 10-second pause. That's all that we need, but just to add a little bit of a pause there. So no issues with having that port associated to the floating IP. So here's the floating IP itself. This is the last thing that we need to do here. Floating IP.yaml. Okay, so here we're taking the floating ID from that public network and we're mapping it to the Neutron port that we've updated in our variable file. And then what that does is it allows us to connect the two together to that virtual machine. And we can also list that floating IP out on the screen so we can see it. So at the end of the playbook, we should see what that floating IP is. And that's the floating IP that we can use to validate that this entire playbook was successful. And take a look at the floating IP that connects to the HAproxy and make sure that it actually works. Okay, so we are going to take a look at the Ansible play and go ahead and run it. So I can hit source or dot and Ansible play. Okay. We can see web server 1 is being launched. We're waiting for web server 1 to spawn as a virtual machine. Okay. Now we're displaying the IP address of web server 1 as we're launching web server 2 from webserver2.yaml. In addition, we see the IP address for web server 2 as we launch HAproxy server. The IP address for HAproxy server. And we were pausing for 10 seconds to allow for the VMs to complete spawning. Okay, so from the web servers, 141 and 142, we're installing Apache. So we're executing our scripts. First, we were actually going to update Ubuntu, so updating Ubuntu. Okay, and now installing Apache. It just takes a minute or so for all those files to be installed. Copying our web page files. Okay, so now we move forward to the HAproxy configuration. So at this point, we're remotely connecting to the HAproxy server using SSH from Ansible. Okay, restarting the service. Now we're configuring the neutron port, waiting 10 seconds. So finally, we can take that neutron port and map it to a floating IP to give the HAproxy an external IP address. Okay, this is the external IP address. Here, a lot of times I like to just do a quick test. Yeah, here we go. Okay, so that shows that we've connected to the load balancer, and the load balancer is actually connecting to my web page. Okay, so what we want to do now is take this IP and just look at it again from here, from a web browser. All right, so this is the IP address, and then we also have the load balancer, HAproxy status, stats. Okay, so this is the HAproxy page, and we can see that there's been 2 connections, 6 to the back end. Yeah, that the HAproxy is the back end, and then these are the 2 web servers. So what I can do is go back to the actual web server. So I should duplicate this real quick. This one we'll hit the web server just to show that it's working. We'll hit it a few times. And we go back to the stats. And we can see that we've had more connections. Another thing we can do is we can force down. Let's take this one down. right? And then we should still be able to connect to the web server because we have one web server available. And then we'll come back to this one and force it down. So now we don't have any web servers. Let's see what happens here. Yeah, see, we're unable, 503, we're unable to connect to the web service. Then we just go back. Let's turn this one back on. Get that one back online. And it works. Okay, so just wanted to show you a couple of things that happened. Host file. So previously, no IP. We added an IP here so that we could read from the host file. We also have the web host. So these are the two IP addresses of our web servers. So that was the purpose of that file. And then in our bars, we added some stuff here. So when we looked at it before, it ended here. So we added the HAproxy IP address to our vars so we could use them in other playbooks. And then the neutron port, we added that as well because we didn't know what that port was until we brought up the VM of the HAproxy, and then we were able to see what port was assigned to it and added it to our variable files. And then we were able to hand that off from one playbook to a later playbook. So that concludes Demo 2, and I hope you enjoyed this demonstration. Just to summarize, we were able to run that playbook and to bring up web servers in an HAproxy, really in like 3 or 4 minutes, right? So very quickly making a resource available as an application stack. Having the ability to stitch together playbooks so that we could take advantage of the OpenStack APIs and the modules from Ansible to simplify that configuration, and then ultimately, connecting remotely to those virtual machines post launch, and updating the guest operating system, the Ubuntu, installing Apache web server, as well as taking an HAproxy and reconfiguring it and restarting services so that we could bring it up online with the awareness of what the IP addresses were of the web servers that it was functioning as a load balancer for round robin type of load balancing. Lastly, from the Horizon dashboard, we can see these virtual machines in their completed state. Again, this was the HAproxy, web server 1, or web server 2, web server 1, and the jump box that we saw originally when we first took a look at this screen. So I hope that this demonstration was valuable to you, and you were able to to see the use case and the benefit of being able to use a tool set like Ansible to quickly build and assign resources and to hand off to other teams who can create environments very quickly and rapidly, making web servers and load balancers available within minutes. And also the value of an OpenStack platform, specifically Cisco Metacloud, where we take care of the hassle of OpenStack. You build on top of it. You focus on your workloads and delivering resources and making the end result available and valuable to your business. Again, thank you, and look forward to the next demonstration.